So field to finish is something that's used in the surveying world, or actually data collection world. It's not necessarily just surveyors that use it. Civil engineers also use it. And it's the process by which we're actually doing drafting in the field. So it entails using the use of a data collector, much like the one that's in the picture here. Um, and that data collector, we're able to use it, um, certain field codes and stuff like that. So in the screen here, if my pen will work. So in the screen here, we're actually able to input information about a particular point or spot or location that we're shooting on the ground or locating on the ground. Okay, so we're giving it a coordinate value. Um, so with that coordinate value, we can also give it information like um, what the point is, what it's made of, things like that. Okay, so the way field to finish works is you would need to use a GPS or some type of angle turning instrument. So, um, like a total station or a robotic total station, and it really deals with input from the surveyor itself. So, if we were to go out and do scanning, we wouldn't be able to do that because, or do field coding with scanning, because you're not actually able to import information about the points that are being collected. So field to finish is unique in that aspect where you do need input from someone running the collector, as opposed to laser scanning or something like that, where you're collecting hundreds of thousands of points in seconds. You really can't field code each one of those points. It's just basically grabbing a point image of whatever you're locating. So with this data collector and the GPS or total station, um, we're doing the office side of the collection, sort of. So we're actually drafting it in the field. Okay, and this can increase productivity tenfold, because what happens is if a surveyor is going out and collecting this information, or as the civil engineer is going out to collect this information about certain points on a project, you can actually put in coding where when you bring it into AutoCAD, it'll actually draft it for you. So what we're going to do in our exercises for Learning Plan 4 are we're going to go through and learn about the field coding, and we're just actually going to do some exercises where to get familiar with the coding. And next fall, when we pick up in our the field applications course, the surveying field applications course, which is surveying 2, when we pick up in that course, we're actually going to be doing real life field to finish field work, where you're going to be doing the drafting somewhat in the field by coding your points. So in the field to finish commands, you collect for like a topographic survey or a planimetric survey that when you're collecting points, you're storing information that looks like this in the rows and columns here. So let's look at point number 1025 here. So it stores, the data collector is storing a point number, a northing, and an easting. That's what the two next columns are. Then an elevation, and then a code. Okay, and that code there is BC. So when you're out in the field and you're doing this, the only thing that you're putting in to the data collector is that code. Everything else is automated in the background from the data collector. So the data collector knows to collect an XYZ coordinate on those particular points that you're giving it for a point number. Okay. So in addition, you can enter more than just one tiny code there. So if you look at point 1024 in that area, it has two different identifiers in the code. So BC, which is the back of curb, and then it says cut, and that would be a curb cut, like where a driveway would be entering the curb. Okay, so the codes are typically entered in a manner that's understandable to the field to finish software. So that software, um, there's a couple different softwares out there that can be used. So if you're using MicroStation, they have a product called Inroads, and Inroads do that field to finish. But we're sort of fortunate because um, we have Civil 3D, and Civil 3D will do field to finish coding for us, which is fantastic. So that field to finish coding in Civil 3D, there's a way to set it up so it'll work, and we'll actually go through that this next fall on making sure we set it up. And I think I have a slide in here that shows like the point identifiers or the line identifiers to make line strings. So that's the software we're going to use, is Civil 3D, and it's a drafting system. So, and that's what we're trying to do, is bring in all the symbols and lines and features that we map out in the field. So in a sense, we're drafting as we're collecting out in the field. So we're trying to make the guy's job a little bit easier, the drafter's job a little bit easier, so he's not constantly calling us because we collected the data, calling us and wondering why we collected a certain point where, and things like that. It'll minimize that kind of activity. Okay, so you actually have to have a good drafting knowledge to know how Civil 3D is actually going to draw these things as you collect them. Okay, so we're going to start with this, and hopefully by next fall, after we get done doing all the stuff next fall, you'll be in really good order with how this all works. Okay. All right. So then, obviously, like we talked about, there's got to be some type of coordination between the field and the office or the drafting personnel. So that person that's in drafting sort of needs to know how you're going to collect all your information. Okay. So, like it says here, it's often most efficient to collect the data for one feature type before beginning another. Well, so that's sort of old thinking. And based on the way I'm going to teach you how we can collect, you can actually collect features as you go. You just have to have a really good memory. That's all it is. And there's actually an exercise that I'm going to have you do where I have feature codes from a project, and they're all points on like a map, and you guys are going to go through and basically connect the dots based off of the point number and the code given to actually draft or hand draft an actual real drawing. So you can see sort of if a field crew goes through and collects data, how it'll actually draw it. And I will tell you, there is a zinger in that drawing. So a zinger is when you have a point that was collected out of order, or it was given the wrong code, and it will draw a line across your whole drawing. So that'll be something you want to look for. Okay. So in Civil 3D software, it'll turn data collector field files into a final drawing. Okay, so it's doing this by matching up that description you're given for the field points and certain line closing codes that you're going to actually use. So when those points are brought into a drawing, that code will actually define what layer it goes on, the type of symbol to use if it's a feature, like say like a stop sign or something like that. You might want to bring in a stop sign symbol, the size of that symbol. So like for a tree, if you have a 6-inch tree, you're going to want it to display in the drawing smaller than a 20-inch tree. So you can give sizes to certain objects, and then also if you're drawing like curbing or a driveway, asphalt driveway or a gravel driveway, you're going to want to bring in the actual line type that would be for gravel or for asphalt. So all this stuff can be set up in Civil 3D, okay? And that's what we're collecting out in the field. Now, it may seem daunting that we have to do all this in the field, but really it's pretty automated. All we're doing is giving it a code when we get out in the field. So back of curb or an edge of asphalt or a tree or something like that, and it'll pick it up in the background. So that field to finish command just uses that one point file is all we're using. So we don't have to think about all the layers and everything else that's going on. We just have to use those codes. Okay. Data file consists of XYZ coordinates. We already talked about that a little bit. And typically it's a CSV file. So it's either a .csv file, which is a comma delimited file, or a .txt file, which is a comma delimited text file. Okay, now when I mean comma delimited, it means that you have, so we like to collect stuff in PNESD format, right? So point, northing, easting, elevation, and code. Okay, PNESD. So when we collect stuff in that format, we want a comma separator between each one of those. So we want a comma after the point number, a comma after the northing, a comma after the easting, a comma after the elevation, and then a comma after the description. Okay, so actually we don't need a comma after the description, but what it's doing in that file, when AutoCAD looks at that file, is it sees, every time it sees a comma, it knows that it goes to the next field it has to populate. So if I have my point, it sees the point number, it sees that comma, and it says, oh, I need to look for the northing, and it'll grab the northing, and then it'll have another comma, and then after that comma, it says, oh, I have to look for the easting, and it'll grab the next number, which is the easting, and so on. So that's how that works for these field to finish programs. That's why it's so important to have a certain file type. So we're going to use CSV files, which can be opened in Microsoft Excel. You just got to remember to save it as a .csv. It won't recognize a Excel file like a .xlsx file. All right. So like I said before, you can bring in symbols and stuff on layers based on the point code you use. So there's a couple different ways that you can do this. So one way is that you're collecting actual features like signs and mailboxes and power poles and trees. That's an actual feature. It doesn't carry a line with it, but there's also that connecting codes to create lines. So a connecting code would be a B for begin a line, an E for end a line, things of that sort. We'll get into what those are here in a little bit. Okay. So like I said before, we have distinct lines with the same code are defined. Well, I didn't say this before, but so I have a distinct code. So say I'm collecting the back of curb on the right side of the street, and I jump over to the left side and I want to collect the back of curb there as well, but I want to do it at the same time. I would actually have to give a 1 after and carry the back of curb 1 code as I traveled. So BC is the back of curb code. So on the right-hand side of the road, I would carry my back of curb over there as BC, and on the left-hand side of the road, I would carry it as BC1. That way the lines don't connect across the road. So every time I was on the left-hand side of the road, I'd use BC1. Every time I was on the right-hand side of the road, I'd be using BC. And that's enough to identify in the program that those are two separate lines that are being used. And the numbering after it can be infinite. So I could be BC 1000 if I wanted to, and it'll work just fine. Let's see here. With this method, all points with the description BC1 will make up one line, while points with BC2 will make up another. So that's just what I just described. All right, so we can also add attributes in there, and the attributes are things like the size of a tree and stuff like that. that would be identified by a space after the point, or after the code itself. So if I had a deciduous tree, say that I was coding and it was 6-inch, I could say deciduous, or use the code for it, which is DTRE, deciduous tree, DTRE space 5, which would mean it was a 5-inch tree. Okay. So the data point description POL would be matched with the code POL, and a point would be drawn with a symbol, and the description is a pole. Okay, so POL is for a pole, like a light pole or something like that. So as soon as I put that code in, the Civil 3D will match a symbol with that code. Now this is all stuff that has to be set up in the background in Civil 3D. It's not something that comes straight out of the box. So that's why we're going to do this next fall. We'll actually go through and add those codes in, so that way you can draft it'll draft your stuff for you. So you can use multiple codes at a time. So if I had, say, let me draw this in there. So if I had a back of curb code, so if I had a back of curb, all right, and I wanted to start that back of curb, I would put a B there. So I'd put a space B. So that's back of curb, begin, and then say at the same spot, there was also a sidewalk edge that we were collecting. We could say SW space B. So basically at this point, at one point, I can have, I'm going to begin on my back of curb line. Okay, so it's back of curb and I'm beginning it. And then I'm also going to begin the sidewalk line, which is a space, and then SW for sidewalk, space B to begin that sidewalk. So at that same point, say I had my point here, I shot that, and I had sidewalk here and back of curb here. So this is sidewalk, and this is back of curb. At this point right here, where they meet up, is where I'm putting this code in for that. Okay, so it's gonna start a line for sidewalk here and back of curb here. Okay, so hopefully that helps out a little bit. A single data point can be used in different lines by assigning multiple codes. Okay, that's what I just basically showed you. For instance, point might be part of both a curb line and a driveway with the description BC and EA. Well, that was similar to the example I just gave you. So in one spot, I could actually have two different lines. Okay, where if I had a edge asphalt crossing the back of curb or something, that's where they would, wherever they meet. You'll see examples of this at the end of the slides. Since field of finish processing spaces in the description as multiple codes, several codes can be defined one single point. So you don't have to. So a lot of the stuff that used to happen is if I had several different things coming into a point, like that example I just gave where I had sidewalk and BC, they used to have to take two shots there. Okay. Well, now you can string together a ton of codes in one point, and the program will see how to use that. So instead of taking a separate shot for back a curb and starting it with the B, and then taking another shot on the same point with the SW for the sidewalk, I can now string those together in one point shot. So I can have a BC space B space SW space B, and it's going to start a back a curb and a sidewalk with that same one point code. So it takes away the idea of overlap. Now, it doesn't mean you can't take more than one shot at a point and give it names and stuff, but it's just it's sort of counterintuitive. It doesn't really help out the drafter at all or yourself. So BOC. So these are some of the codes that we're going to talk about on like how you begin an arc. So you can also draw arcs in field to finish. So BOC will actually begin a 3-point curve or 3-point arc. Okay. So there's also other commands that they'll be able to define that 3-point arc. So anytime you come into an arc, you have to define it by 3 points with Civil 3D or with Field to Finish. So BOC, so if I'm collecting a back of curb and I'm starting a curve on that back of curb, my coding would be BOC or BC space BOC, which will start the curve on the back of curb. A lot of curve and curb going on there. So sort of crappy example, I guess. But so if so I start my back of curb and it's in a curve, and then I go to my second point for my definition of my arc, and that's BC space OC. And the identifier OC means it's a point on the curve. Okay? Specifically at the back of curve. So it doesn't have to be exactly at the midpoint of the curve, but you want to be sort of close to help define it the best you possibly can. And then to close out that curve on the back of curve, we would use BC space EOC, which is end of curve. That's what EOC stands for. And so this is what the string would look like if we were on the back of curve, and these would be the codes you would use if you were on the back of curve. Okay. All right, so OC is that special code used for part of that 3-point curve, for the midpoint of that 3-point curve. So here's, you can use OC several times. So say you have a real long sweeping curve. This string of codes would be something that I would use if I was starting. Okay, so if I have, this is my first point I do, okay. This is the first point, this is the second point, third point that I'm collecting, fourth point I'm collecting, and fifth point I'm collecting, okay? So I'm gonna put in this information to start my curve, and then I'm gonna continue it with this code, because now let's say I walk like 10 feet, it's on a sweeping curve, and I take back of curve 1, and it's OC, so it's on the curve, and then it's still sweeping, so I want to define it further. I can add this one in there, and I can just keep adding them until I get to the end of the curve here, and that'll close out that curve. So it looks like something like this, okay? So I have my beginning of my curve, OC, 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 and then I have my end of curve. Okay, so this would be point 1, 2, 3, 4, and 5. Okay, so this point here would be BC1 space BOC, so I'm beginning the curve. BC1 space OC, BC1 space OC, BC1 space OC, and then this one is BC1 space EOC, end of curve. Okay, hopefully that helps make some sense out of it. And then there's also the CLS command. So the CLS command here can be used to actually force a line to stop or close on the previous point. So if I put CLS at the end of 5 here, what it would end up doing is basically take 5 and it's going to close it on the very first point in that code. So it's going to make a straight line, even though it's not a straight line. I'm not very good at drawing straight lines with my mouse on here. But basically it's going to take 5 and close it onto 1. So it forces it to close to the first point in the name in that string of codes. Okay, so that's what that CLS command does. We don't use that very often. Where you would use that is like if you had islands, like curb islands in a parking lot, or landscaping. Say you were shooting points around landscaping and you wanted it to close on itself, you might use the CLS command. All right, so we talked about the identifying codes, or those special codes to do line work. So this is a snippet right from Civil 3D. They are the line work code sets, and you can change this to be whatever you want them to be for your field crews going out in the field. So these are the ones that are straight out of the box. So right now it says the field code delimiter is space delimiter. You could leave that as a space delimiter. So you could put in something else there if you wanted to. We're going to leave it as space when we go in there this next fall. And but you could put a dash or an underscore or something like that there. It really depends on who you're working for and how they have these set up. But if I look at the special codes, okay, so this is for how it deals with line work, specifically lines. So I have, to begin a line, I have a B, okay? So that's why I was using B. To continue a line, I have a C. Okay, so say I ended out a line on accident and I had like another shot to take to continue that line on. I could go put the last code in, say a back and curb code, so I could say BC, and even though I ended it, I could put a space C after it, and it's going to connect it to whatever line used that previous code that you just put in there. And then we have the E for end, so E will end a line. Barely ever use the E code because the program is smart enough that as soon as you say you put in your code and you add the line work code set as B to begin, it'll automatically end that previous line. Okay, so if I had BC space B for my first code, my second one was BC space B. Let me draw this out quick. Try to be as nice and good about it as possible. So if I had my first point number 1 and it was BC space B, so I began it, okay? And then my point number 2 that I collected is BC. Point number 3 is BC. Okay. So if I have this as a string and it's drawing a line for me, when I come down and I jump across the road or something, I can make my point number 4 BC space B again. It's going to take and end this line string that I was making and start a new one here. Okay, it's going to start a new one. As soon as I put that B in there, it'll end the previous. So you don't really use E very often. Okay, that E code doesn't happen to be used a real lot. Okay, so there's that close command that we talked about. And we can also do horizontal and vertical offsets. I've never used those when I was out in the field because our equipment nowadays will do a vertical and horizontal offset for you, so you can actually key that in prior to even putting the code in there. Okay, same with stop offsets. You don't have to use those. The information on the line segment codes, we don't use that very often anymore because it's all stuff that's controlled by the data collector. But we do use the curve segment codes. Okay, we already talked about the BOC, the beginning of the curve, the end of curve we talked about, and then the OC. Okay, so the point on a curve. Now there's this circle command that you can use that basically what you would do is stand in the middle of an object and type in circle afterward, and then you would give it a diameter. Okay, so you'd put a space and then 5 for a 5-foot diameter. And it would draw a circle around that point in the center. Not used very often. There's not very many times where a circle is a perfect circle is defined out in the field. So typically you're going to want to just use your curve code commands. Okay. All right. So Civil 3D line work code sets. I just showed you those. I don't know why I have 2 slides of that in there. But all right. So let's talk about coding. So I'm going to go through and we're going to code these. I'm going to change my ink color because red can be very hard for some people to see. I'm going to go to a dark red. Okay, so we're going to go through and do this as an example as to what type of code you're going to use. Now, I gave you the code lists in that learning plan, and they're all the DOT codes. So the Wisconsin Department of Transportation has published codes that they use for items. So you're going to want to take and use those codes when we go about doing your homework and stuff like that. And then next fall, when we get out in the field, you'll be using those codes again. So get familiar with them. Also, if whoever you end up working for in your internship this summer, there's a high possibility, high chance that you're going to be using the Wisconsin DOT codes because most companies around here do DOT work, so they adopted their code sets. Okay, so point one here, if I was to code this, it's going to be, my code after this one would be B, L, D, G, space B. Okay, so that's for point one. That would be my code. So it's building, and I'm going to begin it. All right. So if I go to my point number two, I'm collecting out in the field. This is just going to be B, L, D, G. All right. So now that I have those two codes in there, I'm basically drawing a line because I began a line and I'm at number one and I'm connecting it to number two. So building to building. All right, so then we got to go to number three, and that's it looks like a tree. Okay, so they go and they collect it here, and it's a deciduous tree. So it's D T R E. There's no space B or anything there because it's a point code. Okay, so it's identifying just a tree, so a single tree. So there's no reason to start a line there. So there's no, you don't want to put a B after that. Okay, so it's just DTRE. Okay, so then I walk up and I go over to number four, and number four here is the back of curb, we're going to say. It could be like edge asphalt or something, but for this instance, we're going to say that that line is a back of curb. So my code would be BC space B for number four because I'm starting a back of curb line. So number five now, this is a special case, it's a BC space, looks like a sidewalk, SW space B. Okay, so I'm identifying my back of curb at number five, where it crosses here. I started it here at four. Number five is back of curb, and I'm starting a sidewalk. So then I have a sidewalk and I'm beginning it. So it's going to start a sidewalk here. Number six is just going to be sidewalk. Now, why didn't I use my building code there? Why didn't I say B? Well, here's what it would have done. If I would have done that, it would drew a line like this, and then it would have drawn a zinger like that and connected my line. So I don't want to put a B code in here because it will actually draw that zinger, or a building code there, because it'll draw a zinger. Okay, so I'm just going to continue on. So point number seven is also a sidewalk. Okay, number eight is an SW space BC because it's touching the back of curb here. Okay, and then when we go down to nine, it's just going to be a BC again. 10 is a BC, 11 is a BC, and 12 is a BC. Now I could put space E after this if I wanted to, because it's going to end it out, but I'm just going to leave it because I don't see anywhere other occurrence in here where I'm going to be using BC code. Okay, and if I do want to start a new one, I'd just use BC space B and it'll automatically end this where it is. All right, so number 13 now looks like a deciduous tree, so this is DTRE. Okay, DTRE for number 13. Then we jump up to 14. So what's 14? 14 is going to be a building, so BLDG. Okay, and number 15 then, so now our building is going, let me change my color here. Color. Say blue. So my building now, I'm drawing it along this line, 1 to 2, okay? now that I just put into 14, it's drawn it down to this one. And now we're going to go over to 15, okay? So now that I went over to 15, 15's code is going to be BLDG. I apologize for this writing. It's hard to write on a vertical screen. So it's a building code, but so it drew it from 14 over to 15, but we need it to close on 1. So I'm going to say BLDG space CLS. And it'll actually take and draw in the closing line from 15 up to 1. So it will make a nice rectangle, hopefully better than what I drew by hand, because it looks like total crap. But so that actually will take and draw that line in there. So we just basically did field to finish. So it's going to draw it exactly what we'll see here on a picture. It's for the DTREs, it's going to bring in a tree symbol. Okay, for the back of curb, it's going to take and draft a nice line. Oh, one thing I didn't talk about for back of curb here was, and I just caught this, my fault. This back of curb is going to be, we would have to have here, when we got to back of curb here at number 9, we should have said BOC, okay, BC space BOC, because we're starting a curve. I wasn't even paying attention to that. So then our next one here would be BC space OC, okay. The next one would be BC space OC. And then the very last one here would be BC space EOC. Okay? So remember that when you're coding, if we're going to be drawing a curve like that, we got to make sure those curve codes. I totally screwed that one up. So I guess it was a good example. So, all right, so that is the skinny there for coding those. Now I have another example here, okay, of identifiers that show like point symbols. Okay, so trees, similar to those other ones. So you can use this as an example to practice a little bit, but this symbol here would be a coniferous tree. So the code for coniferous tree, you can look it up. It is CTRE is the code for it. But you would go through. So 1 is this iron pipe, and that would be a IP1 is the code for that. All right, so it's going to put a symbol there with the symbol like this for IP, and then 2, 3 are coniferous trees, so you'd be using the CTRE code for those. And then we jump down to a deciduous tree at number 4, which is a DTRE. Number 5 would be your building, so it'd be a BLDG space B because you're beginning the building there. 6 would be BLDG, 7 BLDG, 8 BLDG, okay? But when we jump up to 9, 9 would be a sidewalk, so we would start a sidewalk code there, so it'd be SW space ST, or space B, sorry. ST was the old codes I used to use at my tech. So this would be a SW space B. We go over to 10, be SW. 11 now, we don't want to call it SW. We're going to have to start 11 again now with an SW space B. So if we just say straight up SW, it's going to draw a line like this and then a zinger back to 11. So 11 is an SW space B, 12 will be an SW. 13 will be an IP, space 1 for the size of the pipe is 1 inch. If it's not, you can just put IP. Number 14 is a deciduous tree, DTRE. 15, deciduous tree, DTRE. 16, IP, for an iron pipe. 17 is that building code again. Look at that, we went from 8 all the way to 17 for building. So this would be BLDG. 18 would be BLDG space deck, DECK. 19, DECK for deck. 20, DECK for deck. 21, DECK for deck space BLDG. Okay, because it's connecting where the building and the deck are connecting. 22 would be your building space CLS. So it's going to close it on 5. So BLDG space CLS closes it to number 5. Number 23, coniferous tree, CTRE, and 24, iron pipe, IP would be the code. Okay, so we just went through that coding for those. All right, so let me close the slideshow here. And we're going to go into Blackboard. So I just went through the PowerPoint, and I talked about that feature code list. This here is the feature code list. This is what the DOT puts out. This is only probably half of the codes that they have, but they're in here for your reference. There's quite a few of them. So any example I gave you, they will show up in here. Okay, so let's take a look at this. So as I'm using codes, you would end up using, so say I was looking for the edge of concrete. So I would look at the top here. It says building, fences, trees, control points, DTM, so that's digital terrain model, so that'd be like topographical stuff. And we have edges of points or lines. Okay, so I say, all right, I'm in edges of points or lines. So I can go down and I look in the description here, back of curb, bike path, or bike, commercial entrance, edge of asphalt, edge of concrete. That's what I was looking for. So I was looking for edge of concrete. So the code here is EC for edge of concrete. Okay, so that's how I'd find those items when I go to do my coding. All right.